For us, my relationship, my understanding towards our ancient people are Saguegilnu. Saguegilnu means ancient ones. For us, that means not our grandparents or our aunts and uncles or ancestors. It's ancient ones. It's a step beyond that.
The driving question behind this project, asked by federally recognized tribes, was what protocols exist for identifying ancient native submerged sites on the continental shelf? In order to answer this question, we had to ask ourselves, well, how are we going to do this? This involved development and testing of best practices for 5 interrelated processes considered essential for assessing cultural sensitivity of submerged environments and identifying submerged tribal cultural sites. They included paleo-environmental reconstruction, paleo-landscape reconstruction, tribal engagement, geoarchaeological modeling, and model testing in submerged sites identification survey.
Call it a tribal scientific approach, because tribal people are excellent naturalists. They see a lot of things in the environment that Western scientists don't even see.
And that was really the essence of how we approached the project.
You know, as indigenous people, our goal and our role, our responsibility is to protect Mother Earth.
These people are Ilnu, they're native people, they're all our relations, and we're descendants from them.
Most people think about a paleo landscape as what you can see looking out the window. You see a lot of variability in the landscape. You see uplands, you see marshes, you see parts of ocean, you may see rivers. But on the continental shelf, we don't have that because sea level rise destroyed so much of what was out there. What's left out there, we think, are just individual little puzzle pieces.
When we're posed to the question of where are ancient Native American sites offshore, the first answer we get when we look out at the water is we see the surface of the water. We see nothing of the landscapes that we actually need to find.
So if you're someone that, for example, wants to go and build a wind farm, BOEM is the one that provides you with the permission to actually do that.
BOEM is the federal agency that has been given the responsibility for safe and environmentally responsible offshore energy development.
Very few people know that sea level has risen as much as we know it has. In fact, 11,000 years ago, you could have walked to Block Island, meaning that the entire continental shelf here in the northeast was exposed land.
How do you responsibly develop when you know that there may be seafloor impacts that could potentially impact a cultural resource down there that's important to one of the coastal tribes?
The federal agencies have an obligation to build capacity within the tribes in order to have meaningful consultation.
We don't trust you. I mean, that happens all the time. You talk about consultation and everything's a conference and everything's and there's so many federal agencies that talk so well and ask you what you want. And I mean, it's a beautiful photo op, and at the end of the day, it's a good read, but nobody ever implements anything we say, or we truly don't have the ability to make them kind of changes.
And in order to build a relationship, you have to have trust. And if there's no trust, then all would fail.
So all of that, we kind of said, okay, tribes need to have some people that are familiar with the methods that we're calling best practices and actually participate as a knowledgeable person in Western approaches, but could also bring to bear tribal approaches.
You really need to know the people who it is that you're trying to get from point A to point B with in terms of meeting the regulatory requirements and the permitting requirements.
And the only way to truly do that is to be accepted, is to speak the language, but also to become in a position where we we're equals. We have the ability to train our own people.
It really was about developing a process of identifying the ancient landforms first that were preserved, and then looking at those landforms to identify any cultural deposits that might be within them. And really, that was the goal. That was what we were after, was to try to develop those techniques. With those goals in mind, we needed to go out and actually collect the data that we would use to reconstruct paleo landscapes and also to identify sites. We had to go out and actually try different techniques of doing that. And so in order to meet those goals, we had to do field work. We picked sites that we intentionally knew would provide us with the greatest opportunities for learning the most that we could then apply to the offshore environments. We have geological evidence that indicates that sea level has risen approximately 400 feet in the last 22,000 years since the height of the last glacial period. What's interesting is that through our work with our tribal partners, the Narragansett Indian Tribal Historic Preservation Office, we learned that their tribal oral traditions tell them that overnight waters began to rise and their homes had to be evacuated.
Our oral history says that those are our ancient dwelling places. If that is so, if 15,000 years ago the ancient villages were out there, the ancient places of burial, of living, of ceremony were out on the continental shelf, and we have federal undertakings that are going to impact areas out on the continental shelf, how will federal law identify and protect those places?
And what's been related to us was that that story seems to come from very ancient times, perhaps as long ago as 15,000 years.
We stepped up to the plate and said yes, and we're using their scientific knowledge base and our oral history to meld together, hopefully, new approaches to addressing historic preservation out on the continental shelf.
For us to actually sit there and have a seat and be heard and have a chance to change and influence the processes based on what we knew and relevant to our tribes, it was exciting, but also it was different.
So the first of the study areas that we looked at was a place called Gorton Pond. It's a glacially formed kettle pond in Warwick, Rhode Island, a little bit north of our Greenwich Bay project study area. And the reason why we wanted to start our work there was because of the deep sedimentary record in the pond bottom that we knew existed from previous work that we had done there. When you got to collect the data, you got to collect the data. And actually, coring from the ice is a lot easier than trying to get a boat in the pond and coring from a boat. The sediments that we sampled at Gorton Pond provided us with a sedimentary and paleoenvironmental record dating back to 12,350 calibrated years before present. And the date that we got came from a spruce cone that was found near the bottom of the core in the deepest of the sediments. And it was an interesting find because it gave us a very kind of dramatic sense of what the paleoenvironment was like 12,500 years ago, when the earliest evidence we have of people here in southern New England dates from that period. And it indicated that it was a much colder climate than what we have today.
So from a tribal perspective, that meant what Western science would see as paleo. For us, it wasn't paleo, it was Saguegilnug, and it's part of our history.
In our oral history, we've always been here, and we've always remained here. When we speak to scientists about these cultural sites, it's only because we want to protect these sites.
The second area where we did field research was at a place called Cedar Tree Beach on the north shore of Greenwich Bay. And the primary reason we selected that location was that a local resident who had been walking the beach had found hundreds of pieces of stone tool chipping debris from stone tool manufacture, as well as stone tools themselves, knives, projectile points, arrowheads, spearheads, and a variety of different stone materials that were very interesting and indicated a broad trade network or people coming from a lot of different areas into this particular location over a very long period of time. So Greenwich Bay was clearly, based on the archaeological evidence alone, a very important place for ancient native people. At Greenwich Bay, we utilized multiple types of technologies and approaches to better understand the submerged environment, the submerged paleo landscape. These different techniques and technologies included first remote sensing to get a big picture sense of the geological framework there. This was followed by sediment sampling with vibratory coring to actually get samples of that record that we could then correlate with the remote sensing data to essentially ground truth what we were seeing in the remote sensing record. We also did some very shallow water remote sensing using a special configuration of a marine magnetometer called a gradiometer that measures the Earth's magnetic field. So with the magnetometer, we were able to map the magnetic surface of the Earth within our study area, and it displayed several anomalies that we then targeted for subsurface investigation. Being respectful of the concerns of our tribal partners who would prefer that the bottom and the earth sediments be disturbed as little as possible, both out of respect for the Earth Mother, but also to minimize any potential damages that could be caused to ancestral burial sites or even habitation sites. We used a program of limited subsurface testing. This testing included using a visual sediment probe that allows us to see the different layers of sediments that are buried. We also used underwater archaeological excavation techniques that are pretty common for shipwreck archaeology. We excavated 1 meter by 1 meter test units, limiting the excavation that we did to just 2 locations. So as a result of the magnetic survey and the visual sediment probe investigation and the excavation of the 2 archaeological test units, we did identify a buried submerged paleo land surface based on the paleobotanical evidence that we had was the margin of a freshwater stream or river, and the radiocarbon dates that we got for that surface were about 12 to 1500 years old. We also found evidence of a cultural presence. We found small pieces of quartz chipping debris at both of the locations where we excavated. Finding chipping debris is significant because it indicates that there's a human presence at that location. Finding it in situ, finding it within the sedimentary context and its primary context is important because that tells us that someone was there making stone tools at that location 1500 years ago. And it's something that we tend to forget. The study areas that are way offshore and in deeper water didn't used to be. Those areas used to be close to shore and in shallow water, but they only became deeply submerged and further offshore as sea level rose and rose. These shallow nearshore environments that we're looking at, these more protected environments, actually probably had analogs, if you went back in time, to those places that we were looking further offshore. So in reality, some of the characteristics of these areas that were far offshore and near shore probably were pretty similar. There were estuaries and protected embayments that were shallow if we go back 5,000-10,000 years. Through a systematic scientific approach that was sensitive to and respectful of tribal concerns, we were able to identify paleo land surfaces and cultural material that was located within them.
You have to carry forward an ancient culture passed down in today's life, in today's world.
So we always have to keep that balance between the two. We have to balance those ways. We have to balance both worlds.
The third place that we looked at was out at Block Island. Block Island is a coastal island approximately 11 miles off the coast of Rhode Island. We know there's been a cultural presence out on Block Island for as long as almost as the record that we have in Greenwich Bay. The place that we focused our research on was a place called West Beach, and the reason why we went to look there was because exposed in the intertidal at low tide were deposits of peat, and not just peat, but peat with trees, tree stumps, tree roots growing out of this peat. That's something that's very unusual along the coast of Rhode Island, and something that we thought merited further investigation to see whether or not deposits like that extended further offshore. So the first thing that we did at West Beach was we went to the intertidal deposits of peat and the tree stumps, and we took small samples of the tree stumps so that we could get radiocarbon dates and know about how old those stumps were. So the next step was to see how far did these peat deposits extend out into the water. So two of our tribal research partners and myself and divers and archaeologists from BOEM, we conducted non-disturbance visual surveys approximately 100 meters offshore and extending about 200 meters along the shore to see how much of these peat deposits actually extended into the subtidal zone. Prior to us beginning our field work at West Beach, I had asked one of our tribal research partners if he would perform ceremony.
When we arrive to a site, we like to make it known to our people before us, our ancestors, and just to let them know that we're here.
We asked that we be received in the spirit that we were there, which was to understand more about their cultural deposits that they've left behind in order to be able to protect them. So the non-disturbance visual survey that we did entailed swimming transects that were oriented perpendicular to shore, going out from where these peat deposits were. We positioned them not only where there were peat deposits, but also where there were upland areas on shore. What's significant about this is that when we look to model where sites are usually found, ancient Native American sites are found on land, typically the areas that have the highest sensitivity are the high and dry upland areas. We wanted to know what happens to these upland areas. How are they impacted versus areas that are maybe topographic lows or former topographic lows? And as a result of this visual reconnaissance survey that we did over the 2 years that we were at West Beach, we found some amazing things. The first thing that we found was that it seemed to be the topographic lows that were along the Block Island shore there that were preserved, that were not as impacted by the erosion that occurs as a result of inundation from sea level rise. In contrast with areas that were high and dry, the upland areas that are adjacent to these lows, they seem to be destroyed, completely truncated. The implication for us working in the submerged environment of these findings is that we're unlikely to find sites that would have been in an upland environment prior to inundation. Instead, we're going to find sites and environments that are the interface between land and water, the topographic lows, the marshes, the wetlands, the margins of rivers and ponds. This zone is actually quite interesting because it is that interface between two different types of environments, between dry environments and wet environments. When we were diving in 2016 on the southern study area that we looked at West Beach, and I was in the water with two of the tribal research partners, and one of them, Charlie Machado, I've got a picture of her hovering over this terrestrial landscape that through radiocarbon dating we were able to determine that it dates from about 6,500 years ago.
And to see these old landscapes from a very different perspective, like being under the water, was very, very interesting.
This image of Charlie hovering in her dive gear in this alien environment over this landscape that would have been occupied by her ancestors, that image stays with me. It's just in my mind's eye forever. We found a feature that appears to be a hearth that's submerged underwater. There's charred wood, there's an area of burnt former land surface that is approximately about 1 meter in size, which is pretty typical of a hearth feature. It's from the land surface that dates to 6,500 years old. Yes, these sites do exist. Yes, this is what they look like. And yes, it's important that we try to identify these things offshore because they're here. The sites that we found at West Beach really were the first 2 subtidal ancient Native American archaeological deposits that have been inventoried in the history of Rhode Island. The fourth place that we looked at was a place called the Mud Hole. The Mud Hole is an anomalously deep area, about 67 meters deep, that about 11,000 years ago would have been a large, narrow embayment that would have been attractive to the people. Because it was an open ocean environment, we had to go out and do this work on a substantial vessel. And it provided us to utilize the University of Rhode Island's research ship, the RV Endeavor. When you gather a group of people on a ship that goes out to sea, you really have a chance to get to know people. A big part of the capacity building aspect of the project that we did was to try to improve relationships between diverse members of the communities that are involved in this type of work. Not only members of our research team, but also members of our region's other tribes.
And when we stood there over, on a ship over the continental shelf doing work, I don't think there was anyone on that ship that did not feel it right to their core, that our ancestors were pleased, that energy was pleased. And we were doing what we were doing, but that's when it crossed the line between Western science to tribal and very spiritual.
In terms of the approach that we took to that site, we were still using remote sensing, sub-bottom profiling to examine the geology of the mud hole, and also more vibrocoring to sample the sediments there to be able to correlate the cores with the data in the remote sensing record. We were looking for evidence of any of the relict formerly terrestrial landforms that might have been particularly on the margins of that feature. We were fortunate in one of the cores that we took to find some evidence of what could be one of those margins that came up right at the tip of the core from looking at the potential of the preservation of these sites in an open ocean environment. That seems to suggest that, yeah, there is a possibility, just like we saw in the more protected, closer to shore environments at West Beach and Greenwich Bay.
To be able to come together and say, okay, let's work together for a common cause and try to grow some scientists in the process. And to be able to one day stand on a ship over the continental shelf, taking care of our ancestors and developing best practices and having conversations and debating things and challenging things and learning things, but also to stand there and see our people 3 years from that charge, meaning our students, young students, standing there doing the work, was awesome.
And the final of the 5 areas that we looked at was a place called the Area of Mutual Interest, or the AMI area. And that's a site that's located off the coast of Rhode Island. And we had hypothesized that the bathymetry that you see on the seafloor today bears some resemblance to some of the underlying, or may bear some resemblance to the underlying paleo landforms that are now buried and submerged. We can't just assume that from the existing data that we have a full understanding of what lies below or outside of what those records can tell us. That was the important takeaway from the AMI, that the existing bathymetry, the present bathymetry that you see, isn't necessarily a good proxy for what might lie below it, buried in the marine sediments. The study proved that we have developed techniques and approaches that actually are effective at identifying surviving preserved elements of the paleocultural landscape and identifying cultural sites within them, as we found in Greenwich Bay and also at West Beach.
I mean, we said the words, we made it happen, we actually done it. And that's what we got to reflect on, is what was successful.
I believe there's reasons to trust, and I believe there's hope because of the people we've worked with. They didn't see it as a job, but they seen it as also a responsibility. We built relationships, we have friends now. And when you see a people, you see their dance, you know their story, and then you have an actual perspective of how we actually live and do things, a cultural perspective.
First, I think we learned that paleo environments, paleo landscapes that have been inundated by sea level rise, there are elements of them that have survived that process intact, and that these elements are most likely going to be the margins of former topographic lows, areas that were flooded rapidly, buried, escaped most of the erosive forces of wave action. The second thing we learned was that cultural sites, archaeological deposits, can survive in these preserved paleo landscapes. We demonstrated that with the sites that we found in 2 subtidal locations. It seems unlikely that we're going to be finding archaeological deposits from upland environments. Those environments seem to be the ones that get most affected by sea level rise, that are most impacted by the wave action on the beach and erode. Thus, the models that we have for the onshore environment aren't really applicable to what we're looking at offshore.
Underneath the seabed on the southern New England continental shelf are 5 geologic layers, and each of those layers is kind of like the layer of a cake, stacked up on top of each other. So by understanding each of those geologic layers, we can identify which ones were deposited during the time period that people could have lived on the continental shelf, and also what the environment was like at that time. The layer that we think is most important is named QFE, and that's just a geologic code that stands for Quaternary, which is the time period, and then fluvial and estuarine, which is the environments. QFE appears to represent parts of a fluvial and estuarine landscape that existed after the glacial ice was gone and after the glacial lakes drained, but before sea level rise. So this was a time when it was likely that people lived in the area, and so we think that this layer is probably the most important place to look for preserved paleo landscapes. This is just a hypothesis for now, but at West Beach and at Cedar Tree Beach, tribal cultural material was found in what we think was the QFE layer, which suggests that our regional geologic model might be on target. If you have it and you're building a project that is likely to disturb it significantly, then you also are likely to be disturbing something that could have cultural significance.
We did what we were supposed to do. And if that can grow and it can build the capacity and build the scientists in tribal communities to work with Western scientists, new scientists that are coming up through the ranks, what a perfect place for us.
The more we can improve the relationships that we have between these communities, the more engaged we can be, the greater likelihood we have of being successful in our endeavors to identify sites offshore.
We're taking care of our Saguegilnu, our ancient ones. We're doing some things that no one really thought could be done or would be done.
You know, they can become the professionals who use their tribal knowledge, their tribal identity to help shape those fields of research in ways that make sense from a tribal perspective.
The way to actually join or try to build anything out of it is building relationships, and that's the main target. Building relationships with the people the landlords of the people, the indigenous people. That's very important.
Everybody wishes that things weren't challenging, but we can't improve, we can't do better in any way unless we identify what the challenges are and what the problems are.
I think our best chance of being effective in improving the protocols that we've begun to develop with this project is to work together.
And speak up. It needs a voice. There needs to be a voice there, because if I don't, then there isn't one. It's lost.